Good morning, Math 7 students. We're here today. We're going to look at percent proportions and equations unit. However, this is going to be a percent proportions problem from New York State. So this is on last year's Math 7 test. Yeah, it looks kind of intimidating. Looks a little scary, but no, don't be worried. Don't be worried at all. You should be coming into this problem with a smile on your face, right? So be positive. You'll be fine. We're going to talk a little bit about what Mrs. Franks talked about in class. She has a great system that she gave you to use to solve a problem like this. So, according to Mrs. Franks, right, our first step is to read the problem. Have to do that first. Always read the problem. So let's do that. A worker at a snack stand opened a new box of cups. The first day the worker used 30 cups from the box. The second day the worker used 15% of the remaining cups in the box. A total of 90 cups were used on the second day. What was the original number of cups in the box before any cups were used? Okay, so we read the problem. Our second step is to annotate, right? We're underlining or highlighting. Important information. So I got my highlighter here. Let's look at the first sentence. So it says a worker at a snack stand opened a new box of cups. That's fine. All right. So that's something we're not going to underline. It says on the first day the worker used 30 cups from the box. So I mean, we could say the worker. We could underline that whole thing. I'm just going to underline used 30 cups from the box. Right. So that's something that we need to know. So we got the first one. Next, the second day, the worker used 15% of the remaining cups in the box. So, once again, we can decide first day, second day. That's fine. So, second day, we'll put that. Second day, the worker used 15% of the remaining cups. Okay? And I'll actually go back and I'll highlight that too, because we're going to find that the first day may be important. And I'll throw in the worker used. That's fine. So not a big deal. Let's go to our next sentence. A total of 90 cups were used on the second day. That's definitely something we want to highlight. So, a total of 90 cups were used on the second day, right? And then obviously we need to know what the question is asking us. So we'll go back and I'll highlight this again in yellow. What was the original number of cups in the box? So we want to know original number of cups in the box before any cups were used. So we'll highlight that. So a lot of information, a lot of stuff going on here. So we did step 1, we did step 2. We read the problem, we annotated the problem, we underlined and highlighted the important information. Now, number 3 is we need to know what the part is. What's the part of this problem? Okay, so what's the part of this problem? Now, you got to be careful with this. The part of this problem is going to be the cups that were used, right? So that's going to be the part. Do we know how many cups were used? Right? You got to read a little carefully, right? We looked at the first day the worker used 30 cups. The second day the worker used 15% of the remaining cups. Okay, so we don't know how many cups there are, but we do know a total of 90 cups were used on the second day. So we have to be a little careful here. If we want to know the actual part, we actually, think about it for a second. You can even pause me if you want. But we actually have to take 90 plus 30, right? And that's going to give us the total number of cups used. Now, you got to be careful when you say total because we're still dealing with a part here. This was part of a total number of cups that we don't know. So 90 plus 30, right, should be 120. So our part is 90 plus 30, which equals 120 cups. And that was used over 2 days. Okay? So, step 4. We got our part. We need our whole. Right? What's our whole? Well, do we know what the total number of cups were? No. And that's our whole. So what was the original number of cups in the box before any cups were used? Well, we don't know that information. So if we don't know that information, that becomes a variable. And in most cases, we use the variable x. That's the information we want to know. And that's what the question is telling us. What was the original number of cups in the box before any cups were used? And then the last thing is, do we have a percent that's in this problem? Yes, we do. What's our percent? Yep, 15%. So we have 15%, right? Or the 15. So the 15 is our percent. So we read the problem, we annotated the problem, meaning we underlined and highlighted important information, and then we went and used our PWP, our part, our whole, our percent. And we had to do a little more work to find out what our part was, but we were able to get that. It's actually 120 cups. So this is something that they will normally do. They'll make you, they'll add in an extra step before you can actually get to setting up your proportion. So if we set up our proportion, right, we have part over whole. So part over whole, right, would be, we have 120, because we have our part, over whole, which is x, and then we have our percent, right? We have our percent, which is 15, over what's the maximum or the total amount that a percent is out of, right? And we always need to know that that's 100%. Everything's always out of 100%. So that makes sense. So we look at things, we have part over whole, right? We have part over whole. And then we have our percent over our percent, right? Which is our whole percent, which is the same thing. That's what it's going to be out of. This is our part of our percent. So what I'm going to do is, I don't want to mess around, so I'm going to cross multiply, and that's what I'm most comfortable with. Could you scale up? Yeah, but it could create some confusion and some issues with the math. So my comfort level on this problem is to cross multiply. So when I cross multiply, 15 times x is 15x. 120 times 100. Now, you can add zeros, you can do what you want, but we do need to get used to using our calculators, and it's good to have that warm fuzzy feeling like I talk about all the time in class. So that's what you're going to want to have. That's what you get by using your calculator. So we get 12,000, right? You could obviously, just take 12 times 1 and then add the 3 zeros to it. But, I put it in my calculator no matter what. So we have that. Now, we're just solving basic equations now. I put my center line down. I know that I have multiplication here, right? So the opposite of multiplication, you said it correctly. It is division. So we got to divide both sides by 15. When we divide both sides by 15, the 15s cancel out. My x is alone. And now we're going to take 12,000 and we're going to divide it by 15. And we get 800. 800 what, though? That'll give us the final answer. It'll be 800 cups. So that's how many cups that they started with before they opened the box, 800 cups. So if we go back and we look at our problem, because it's a multiple choice problem, do we have 800 as an option? Yes, we do. 800 would be choice D. So multiple choice problem, but showing your work and using the strategies that you've learned in class are of great help. So, let me know if you have any questions during class.